Linear interpolation is an estimated value between two known points. Its formula is A plus the difference between B and A multiplied by t. As shown on the graph, it represents all the intermediate points between two values. With this equation, we can program our very own Lerp function. Our method is identical to the equation. But how does this make an image? We begin by spawning a canvas consisting of thousands of pixel objects that correlates with our image's width and height. Each plane on this grid represents a pixel. Each pixel's position is calculated using its x and y coordinates as well as its scale. When the canvas is finished spawning, we then iterate through the canvas GameObject array. For each pixel object, we interpolate its color towards its corresponding pixel color specified by an input image. The result is a smooth transition between images. The camera movement is also controlled via linear interpolation. Extrapolation is an estimate on what a value should be given two known points. When t is greater than 1, we are extrapolating beyond the scope of our known 2 points. Extrapolation is commonly used for lag compensation in online games. The following tests simulates latency in online games. The coloured cubes represent the temporal differences between the client, server, and a remote player, as shown in blue, green, and red. We simulate latency and packet loss to see how interpolation is used to help compensate for latency. Every 200 milliseconds, the player sends an update to the server. After a brief delay caused by artificial lag and packet loss, the server updates its position. If the update frequency is too slow and latency is high, this results in a lot of teleporting and jittery movements. For smoother movement, we can interpolate to the updated position. This works quite well, providing there is minimal latency and interruption to player position updates. By adjusting the latency, we can see its effects on the server's ability to reliably tell where the player is. Though the motion is smooth, latency causes considerable delay, especially for the remote player. To compensate, we can use a mix of extrapolation and interpolation in a technique known as dead reckoning, where we estimate the player's position based on their last known location. Dead reckoning is used frequently in naval settings to estimate where a ship should be based on their last known location, velocity, and time. When it extrapolates beyond the player's position, it corrects itself when it receives an update. This is why when players disconnect in online games, their avatars often continue running in a straight line. In conclusion, this video has detailed the various applications of linear interpolation and how it is used for smooth transitions between states, and how extrapolation is used for lag compensation in online games. Linear interpolation is everywhere in modern technology, from animations to movement in video games. Anything requiring smooth transition between 2 points likely uses some form of linear interpolation.